Good morning, ladies and gentlemen. Welcome back to Earth Science. We are going to move on to a new section today. A section called Rocks. Breaking new ground here, right? It's in Chapter 3, the very first tab titled Rocks. This is going to give an overview of the three different types of rocks, and then we will go into them individually over the next chapter. Okay. So, for those who have an opportunity, in the very beginning, we will watch this 3 or 4 minute clip about an individual who goes over the different types of rocks, the 3 different types. Really good tutorial and video. I would recommend watching that. After doing so, let's go over what they are. So, a rock, by definition, is a mixture of materials, mineraloids, glass, and organic matter. Okay? That's the definition of what a rock is. But there are 3 main types of rocks. The first one is igneous rocks, or igneous. Excuse me. It forms from the cooling of magma and lava, so it can cool in the ground or above ground. Sometimes forms deep in the earth, as I mentioned, as magma does, because it cools off slowly like an oven that got turned off but had the door closed still. It takes a long time to cool down that mass. Lava cools quickly because it's on the surface, or while on the surface it also can hit water, which rapidly cools it. And igneous rocks take many curious shapes and textures due to the amount of time it takes to cool, as well as the mineral content found inside the magma. Here are some images here of what they would look like. You have vesicular basalt, so it's porous due to gaseous bubbles trapped in the lava when it cooled. No visible crystals. This one has large crystals, very evident of your standard granite. This one is similar to this one. This is more of a cinder base with similar textures. This is similar to this, except this is considered a salt and pepper. This is kind of an in-between. This is an andesite. You will learn about that later on. And then this is volcanic glass. This is void of any minerals because it cooled rapidly on the surface. Next category is metamorphic rock. Metamorphic rock forms from rocks being pushed deep into the earth, where they change chemical compositions. Okay? Due to, this is the most important piece, extreme heat and pressure. As the rock heats up, it begins to feel pressure, it twists and bends, and the minerals tend to align, as you can see here in this image, causing some pretty awesome color and texture. That's not the only way it happens, but this is a common procedure. If I make it bigger, a common procedure in which you will identify metamorphic rock. But some others don't have them. These don't have them. These have more bands and then some texture of flowing. These are formed from clay minerals. These could be formed from other minerals. And this is formed from olivine, making peridotite, a green mineral rock forged deep down, and with heat and pressure it creates a different green rock called peridotite. These are just examples. Okay, so metamorphic rock due to heat and pressure, and sedimentary rock. These form from weathered material of all other rocks, as well as from minerals that come out of liquid solutions. Okay, this right here is another one. So there's 2 ways you can form a sedimentary rock: through weathering and erosion of material, and through liquid precipitation. Much like the crystal lab we did. You dissolve the mineral halite crystals into the liquid, and later on you precipitate them out. Okay? And common, they are most common they are our most common surface rocks on the planet, and they're formed from swamps, lake beds, ocean bottoms, and sand dunes, to name a few. Here's some examples here. Some really pretty examples. This is common in Arizona. This is as well sandstone up close, limestone, etc. Okay? Alright, so as rocks break down, they go through what is known as a rock cycle. Okay, really important. A rock cycle. The video in the very beginning explained this more in detail. Rocks form, change shape and texture, break down due to weather, and are moved to other locations due to erosion. As they break down, they might get forced deep into the earth, where the rocks start to soften and become pliable, or metamorphic rock. In this rock, if the rock's journey continues, it may begin to melt, turning into magma, where it eventually explode out of a volcano, cool off, and become an igneous rock on the surface. So there's a great cycle in which it continues to go through. So now you understand a little bit about this. We're going to complete what's called the Rock Observation Lab. And we'll do a rock cycle lab a little bit later. What I want you guys to do is identify 4 different rock samples that I have laid out in the back of the room, whether or not they're igneous, metamorphic, or sedimentary. That is your job. And once you do that, I'll come around and I'll grade them. Alright guys, let's get going.